Good afternoon. Today we are doing our last objective in Unit 4, CO28. I can calculate simple and compound interest. Whew. This is a big one for when you get older and you're doing stuff like loans. You go to college and you need a loan. You get even older and you want to buy a house and you need a loan, buy a car and you need a loan. We need to understand the interest that we're gonna have to pay back on those loans. You get a credit card and you have to pay interest on the money that you don't pay off right away. Interest makes a big difference, and there are the two types of interest, simple and compound. So having financial intelligence can help you make informed decisions that can end up saving you a lot of money in the long run. When you borrow a large amount of money from a bank or make a large purchase on a credit card, you are charged interest because, for example, $20,000 today won't have the same value by the time you eventually pay it back. So my original mortgage I had, first time I bought a house, it was a 30-year mortgage. So we were making payments on it. We were gonna have to pay for 30 years for my first house. We sold it and now we have a different house, different mortgage plan. But that first one was for 30 years. So that money back in, when did we buy that house? 2000. We bought the house in 2000. That money is going to be different in 2030, right? Because of inflation. That percent of increase, inflation goes up. That money isn't worth as much. Think about money 100 years ago. What you could buy for $1 is not the same that you can buy for $1 now, right? Think about how a can of pop, that bottle of pop we learned about in earlier objective, where it was 99 cents in whatever year, and now it's $2.19, right? Money changes over time on how much you can actually pay for it. So they charge that interest. You're borrowing our money, it's going to be worth something different in the future, so we're charging that interest on it. If you weren't charged interest, the company you are borrowing from would lose money. And these companies are about making profit. So they're going to charge you interest. Even on small loans or purchases, charging interest is a way for companies to make money in general. They want the profit. Interest isn't all bad though. Money that's deposited into certain types of savings accounts can earn you interest. So if you have special accounts set up, your money can make money for you because you're getting interest on that money in your savings account. So sometimes the interest works in your favor, but a lot of times it doesn't. So for this lesson, we need to understand what the different terms mean. And then we're going to have different equations we're going to use, different formulas. We need to be able to find, just like the part in the whole and the percent, we need to be able to plug the correct numbers into our equation in the right spots. We're going to be doing that with this too. So the principal, which is the P, is the original amount. What you took your loan out for, the deposit you made in the bank. That original amount. The rate is the interest rate. So you might hear an older sibling say, yeah, I took out my student loan and I got it for a 4.2% interest rate. Or, gosh, Mr. Gambino's car loan that we just took out was like a 3.5% interest rate, right? So different amounts for that interest rate. We're gonna see how that plays in effect. You want a really small rate if it's something that you're gonna owe. Right, you want a big rate. Ooh, my savings account's getting me a 10% interest rate. That's a good thing. You want the bigger number if it's going to be making you money. small number if you're going to be having to spend it. T is the time. That is how often the interest is applied. Now, simple interest, because we have two different types of interest we're learning about, simple and compound. First, we're going to focus on the simple interest. Simple interest is interest charged on the principal. Only. So it's only charged on that principal amount. An example would be $100 loan at 10%, simple interest annually. Okay, so that means every year, because it's annually, so we have to look at when we first take it out, here's our balance. What would our balance be when we first take out that loan? What is our principal amount? Henry? $100. After year one, we're going to have interest put on it. So to calculate what that interest is going to be, we're going to use this formula. The principal times the number 1 plus rate times the time. So I'm going to use that formula for my $100 after 1 year at 10% interest. So the math I would do, the first year it's easy. First year we could say, well, what's 10% of 100? Who knows 10% of 100? Finley? 10. And we're going to add it on. So that first year we don't need the big formula. We could just say 110. That's easy. On year 2, with the simple interest, because we're using something simple like that 10%, we might be able to find out what that is, but we're going to try using our formula here. Our principal amount was at 100, so we would do 100 times 1 plus our rate times our time. So our rate is 10% times the time, well, it's 1 year, annually. It's only 1 year. So it would be 1 plus 0.10, which would be 1.10, times, oh wait, nope, sorry. It would be a 2, you are correct, because it's 2 years. So that 0.12 times 2, thank you. So what is 0.12 times 2? Joe? Because we have to do 0.12 times 2, then we can do that 1 plus it. So what is 0.1 times 2?
Oh,
2.2. Then we add 1 to that. We add 1.
1.2.
1.2 times 100. Who's got their calculator up? Victoria. 120. Now, when we do it on our calculator, we don't have to do all those little pieces. We could put it all in at once. This is where it comes in handy to have our big calculator that we bought at home instead of borrowing one of my simple ones from back at my back counter. Because this one has parentheses on it. I can make that equation, that calculation that I wrote down on my calculator, but I have to be incredibly careful that I'm putting it in correctly. So I had my principal of 100, then I have my parentheses. Can we see that? And then in the parentheses I have 1 plus, let me see, was it 0.1 times 2?
Yeah.
And then I have to close my parentheses. So you have to make your calculation on your calculator look just like what you wrote on your paper. And then it equals 120. So you don't have to do, oh, I've got to multiply, and then I have to add, and then I have to multiply. Write the calculation out on your paper so you know exactly what you have to put, where you're putting it onto your calculator. Does that make sense? You truly have to write that calculation out on the paper first. Make sure you have everything in the correct spot, then put it into your calculator. Why am I being so specific that you have to write it out? Why would I do that, Clara?
Because if you mess up on your calculator, you can look at your paper and see what you did wrong.
Yes! If when you get the answer on the calculator, you go, that doesn't logically make sense. That just seems way off. You can figure out where that mistake happened. Okay? Mental math, no, we don't need to try to do it all mental math. We're getting into the more complicated stuff. Joe?
Since we're doing year 2 here, would it still be multiplied times 100 or would it be 110?
So what is the P?
The principal.
The principal amount. So remember that principal amount is that original $100. So you always start with the original. That was a good question. How do we feel about that? So let's look at what our next year would be. If the next year is 3, write out what that calculation would be. Use your calculator, put our formula into your calculator and tell me what would the interest be at year 3. Emily. So, it's easy to say, ooh, we're using a simple problem, I can follow the pattern. But we do something easier when we're learning it. We truly need to make sure we're getting that when we put it into our calculator. Don't just say, well, I can see the pattern, it's going up by $10 every time, I'm just going to write that. Because it will not be that easy on your homework. So I'm going to give you year 4. Actually, truly work it out on your calculator. Make sure you are doing it correctly. What number should we get if we do it correctly, Victoria? $140. If you're not getting $140, you're doing something wrong with your calculation. Everybody should have their calculator out. So everybody should be making sure that they are using their calculator correctly. Henry, where's your calculator?
Oh.
All right, that is simple interest. Now let's look at what compound interest is. using the same principal rate time letters that we're using, they mean the same thing, we're just gonna have a different formula. So compound interest is interest applied to a running total on the loan. So it's applied to both the principal and accrued interest. So when Joe asked, should we be using 100 or should we use that 120? Which number should we use? This is where things change, okay? So our formula is going to be a little bit differently. So with the simple interest, it's just applied to that original principal amount that you took out. Compound interest, whew, now it's not just that original amount. Now they're taking into account all the interest over the years that you're gonna also owe. And it's going to make the amount that you have to pay back at the end a whole lot more. Henry? Nope. So, we're gonna use our same example of that $100. So we're taking out a $100 loan at 10% interest. Or, sorry, compound interest, I have to specify. That compound interest annually. So this is where it really matters that you are reading for meaning on your problems. Am I using the simple interest formula or the compound interest formula? It's going to change our answers dramatically. So now this one we're taking out a small amount of $100, so it's not going to be super dramatic, but it will change it, right? We're going to see the amount that we owe change. Our compound interest formula is that principal times, in parentheses, 1 plus the rate to the exponent to the power of the time. So we're going to use exponents with it. Instead of just rate times time, all of a sudden it's going to go to that exponent. So remember, if we were to work it out by hand, right? Order of operations, we do the parentheses first, then we do our exponent, then we multiply it by the principal. Let's see how it changes our answers. So we had our year, and we have the balance. When we take it out, it was that $100. So we're starting off the same. At 1 year, what do we get? So we're going to do that $100 times 1 plus the rate of 0.10 to the first power, because it's the first year. What do you get as the amount that we owe for that one? Laura? For 1 year? Did you put this calculation in? So we're doing it for 1 year first. So inside the parenthesis, 100 times, in parentheses, 1 plus 0.10 parentheses, exponent power of 1. Do you guys remember how to do the exponent power? Let's give you a quick reminder. So on your calculator, you would have 100, oops, let's turn it on, 100 parentheses, 1 plus 0.10, parentheses, and then we have to do the little caret. So remember that little arrow up to the first power, because it's 1 year. So you need that little caret to make it go to that exponent. Doing it that way, you should have gotten that same 110, because our exponent was only 1. So it didn't change from our simple interest for 1 year, because we were just working with the exponent of 1. So it would still be 110. Now at the 2-year mark, we were at 120. What are you at the 2-year mark for the compound interest? Joe? 121. What about at the 3-year? So what's changing is your exponent. So as that time is changing, your exponent is changing. To find it at the 2 years, you'd put a 2 for your exponent. Now at the 3 years, we're putting a 3 for the exponent. What is that, Henry?
133.
Nope. Ellie?
330.
Nope. Finley? 133.1. Those decimals matter. I know you don't have your calculator with you right now, but just know you can't just make a guess when we're doing the work. Okay? So it matters. Now do it for the 4 years. Same formula, but this time our exponent is a 4. What would it have been for the simple interest? Look at our simple interest, the table up above on your paper. What would 4 years be for the simple interest, Clara? 140. What is it with our compound interest, Clara? 146 and 41 cents. Those cents matter. Banks, credit cards, they care. Make sure you are rounding to that 100th place. Make sure you are rounding correctly. If you're off by a penny, it will be wrong. Banks care about those little itty bitty pennies. Okay, make sure you're rounding correctly. So, compound interest, using a small number like 100, it's not a drastic difference, but over time, will we see a drastic difference? Yeah, because that 100 with the simple interest was only going up by $10 each. This is going up a whole more and more and more the longer the time goes on. It's going to be greater. So if you're taking out a 30-year loan, it's going to be a much bigger difference.
Well, like, will these types of questions be on the test?
Oh yeah.
Can we use like calculators?
Oh yeah. We're at big kid math. That's why I showed you how to put the calculation into your calculator. Most definitely. Okay. The important thing is to remember how to put it into your calculator. So let's look at our second page. Use the formulas for simple and compound interest to answer the questions below. Show your work. That is, show how you are plugging in the values into the formula you are using. So write out the calculation, and then make sure what you put into your calculator looks exactly like it. So what I would do, because I don't like flipping back and forth, Evelyn, what are you doing right now? She's doing exactly what I was going to tell you to do. She's looking at that front page, and she's writing the two formulas on the second page. So you don't have to keep flipping back and forth. So what is my formula for the simple interest? What's the formula? Who can tell it to me? Go.
P parentheses 1 plus rate times time.
So write that at the top of your page. Then we're gonna have compound. Who can tell me the formula for compound? Ellen?
P parentheses interest plus rate.
Not interest. There's no I. Remember, that's the number 1.
Oh,
Because we had our 3 different words. Interest isn't, there wasn't an I. So principal, rate, and time. So we've got 1 plus,
rate parentheses the thing.
exponent for the time. Ellie?
I have a question.
Yeah.
So like, first and first, when it says like use the formula, can we like use both of them?
So we have to read the question. The question's gonna tell us.
Yeah.
So look at our first question. Your bank gives you a $1,000 loan to buy a jet ski and charges you simple interest at 12% for 3 years. So, key things that we need to know. And you're going to actually mark up your word problems, so you know these things. You're gonna circle simple interest, so you know to use the simple formula. 12%. Which of these letters am I gonna put above the 12%? The P, the R, or the T? Hold the R. The R, because that 12% is our rate. That's the interest rate, the 12%. So, what do I put above the 3 years? Laura? The T, that's our time. It's lasting for 3 years. I still need a P. Where do I put the P? Elliot? The 1,000, that's my principal amount, that $1,000. The original amount that you take out. So now, Elliot asked, do we use both formulas? What do we, our question tells us. So you're gonna circle if you're using the simple or the compound. Make sure you use the correct formula. I tell us to circle it for a reason. Because there are a lot of times that kids get it wrong because they use the wrong formula. So circle that simple or compound. Make sure you're using the correct formula. So we're using our simple formula. We're going to use that first one. Our P I marked, I know it's $1,000. Parentheses 1 plus my rate is that 12% times our time of 3 years. So that is the calculation that I am going to put into my calculator. 1,000, parentheses, 1 plus 0.12 times 3, parentheses. If I put all that into my calculator, what do I get? Laura? 1,360. That is how much interest is earned on that loan. Sorry. That is the total amount. 1,360 is your total. I should have read the whole question. 1,360 is that total amount that you pay at the end. This question is asking, well, how much of that is interest? So how do I find that answer? Victoria? I need to subtract that principal amount, right? So if my total amount is going to be 1,360, I need to subtract that principal of 100. So that is my total. I'm going to subtract the 1,000. I'm subtracting that principal. How much interest am I being charged, Clara?
$360.
$360 in interest. There are two questions in my problem. My answer has to have two answers. So when you're using that calculation, that formula, you're finding the total amount at the end of the loan, you are paying off $1,360. Altogether, that's what you paid the bank. $1,000 for that principal amount, $360 in interest. Does that make sense? Okay, so as you're doing your questions, make sure you're looking, circling if it's compound or simple, marking where your principal is, what your rate is, what your time is, and answer both questions, or whatever questions the problem gives you. Go ahead and work on it. We don't have a ton of time. Here's the thing. Tomorrow is a work day, right? It's a retake day. There's Khan Academy. You might be thinking to yourself, oh my goodness, I have so much to do tonight. When are we going to correct this? Monday. So know that you have until Monday, but don't put it off and say, oh, I'll do it later, and then forget about it. So it's your responsibility, if you don't get it done tonight, that you get it done before we correct on Monday. And that doesn't mean do it during other classes. It means it's homework, do it at home. Okay? Remember, Khan Academy is due tonight. Tomorrow we will be making the video for Packet 4. If you are watching at home, I hope you are well, and I hope to see you soon. Have a wonderful day, and don't forget to like and subscribe.